This week we're going to concentrate mostly on just acids and base titrations. If you'll remember, a titration is when you take a solution of unknown concentration and you're trying to figure out the concentration by using a solution of known concentration. We often do this when we're dealing with acids and bases. A strong acid of known concentration is slowly titrated into a base mixed with an indicator, or you can have a strong base of known concentration added to an acid mixed with an indicator. We're not going to be using indicators so much. We're going to be using pH probes. The indicator changes color to signal the arrival of the endpoint. The equivalence point is when you have equal amounts of acid and equal amounts of base. So you have the same number of moles of acid, same number of moles of base. There's three types of acid-base titration: strong acid, strong base, weak acid, strong base, and weak base, strong acid. There's also weak acid, weak base, but we'll get to that later. So we're going to start with the easiest one, strong acid, strong base. And if you remember, the reaction for a strong acid plus a strong base is this down here. H positive plus OH negative makes water. And what we're going to do is we're going to do ice charts. The only difference is when we're doing acid-base titration ice charts, everything is not going to be in molarity, it's going to be in moles. So here's the scenario. 30 mils of 0.5 molar strong acid is titrated with 0.5 molar strong base. You need to find the pH initially of 0.5 molar hydrochloric acid, the pH after 15 mils of sodium hydroxide is added, the pH after 30 mils of sodium hydroxide is added, and the pH after 45 mils. Now this right here, 30 mils of 0.5 molar sodium hydroxide, when that's added to 30 mils of 0.5 molar hydrochloric acid, that's going to be the equivalence point. Okay, so what is the initial pH of just plain 0.5 molar HCl? Well, that's going to be easy. All you do is press negative log 0.5. You get a pH of 0.30. Easy enough. What's the pH after 15 mils of 0.5 molar sodium hydroxide is added? So the first thing I said, you have to find the number of moles. So the number of moles of HCl, this is my liters, my molarity is 0.015 moles of HCl. Here's my liters, here's my molarity, here's my number of moles of sodium hydroxide. So now we're going to put these two moles in an ice chart. Here's my reaction, H plus OH makes water. Here's my moles, number of moles of acid, number of moles of base. Notice I have more moles of acid than I have moles of base, and so all of these moles of acid will neutralize the 0.0075 moles of base. So I'm going to lose all of that, or that all of that base is going to react. I'm going to lose all of that H because it's a 1-to-1 ratio. And that's going to leave me with 0.0075 moles of acid and 0 moles of base. Now I need to take this moles of acid, divide it by my new volume, because I had 30 mils and 15 mils, it's 45 mils, to get my new molarity, this 0.0075 moles, divided by 0.045 liters, 0.17. That's my molarity of H, so now I can press negative log number, 0.77. Find the pH after 30 mils of sodium hydroxide is added. Well, once again, this is the equivalence point. 30 mils of 0.5 molar OH is added to 30 mils of 0.5 molar H. That's the equivalence point. The equivalence point is when I have the same number of moles of acid, same number of moles of base. So all I have left is water, which has a pH of 7. Finally, find the pH after 45 mils of 0.5 molar hydroxide is added. So I'm going to use the same number of moles of acid. Here's my new number of moles of base, 0.045 liters. That's my volume. That's my molarity. Here's my moles. So I'm going to have a new ice chart. I'm going to plug in my moles, 0.015 for hydrogen, 0.023. So now notice I have more base than I do acid. So I'm going to neutralize all of this acid, and I'm going to have leftover base. Minus 0.015, minus 0.015. This will be 0. This is going to be, what, 0.008. This is in moles, so I have to divide this by my new volume, which is 30 mils plus 45 mils. That's 75 mils. So moles divided by liters, 0.008 moles divided by 0.075 liters. It's 0.1, roughly. Okay? Now that's my moles of what? OH. So when I press negative log number, that's my POH, and then I have to subtract that from 14 to get my pH of 13. This typically is what a strong acid, strong base titration curve looks like. You're going to start down low because we start with a strong acid, and then you're slowly adding your base to it. Notice it starts to slowly crawl up, and then once you get close to the equivalence point, it jumps straight up. Okay, here's your equivalence point right here where the pH is 7. Notice that we end up nice and high because we're ending with a strong base.